Vanakkam friends, those who have not subscribed to my YouTube channel, that is Trinity Cultural Academy, so far kindly subscribe to receive upcoming videos. This presentation is continuation of my previous presentation on soil chemical properties. During last presentation, we discussed about soil colloids and clay minerals. In this video, we discuss about ion exchange capacity, base saturation percentage and soil pH. First one is ion exchange reaction. It is a process by which ions are exchanged between solid and liquid phase or between solid phase if in close contact. It was first identified by Harry Stephen Thomsway in England during 1850. There are two types of ion and they are cations and anions. The cations carry positive charge and examples are calcium, magnesium, hydrogen, ammonia and sodium. The anions carries negative charges like sulfate, chlorine, phosphate and nitrate. Ion exchange is due to presence of residual positive and negative charges. Good friends, now discuss about the mechanism of cation exchange. Generally, clay particles have negative charges and cation are attracted to them. Cations are held on surface of small particles of clay and organic matter electrostatically. This occurs when cations like calcium and potassium or ammonium are applied through fertilizer and soil amendments. Exchange of these cations takes place with those ions held on colloids. Next, we will see cation exchange capacity, in short CEC. It refers to sum total of exchangeable cations that a soil can absorb, and also it is defined as amount of cation species bound at pH 7. CEC2 is measured in moles of electric charge. Let me now discuss on factors that are influencing CEC. This first one is soil texture. Increasing clay content will increase CEC. Increase in organic matter, CEC increases. Nature of clay, montmorillonite and vermiculite have higher CEC than kaolinite, chlorite and illite. The final factor is soil reaction. CEC increases with increase in soil pH. The next important aspect is anion exchange capacity. Here, replacement of one anion by another anion on the positively charged ion. Lower pH have higher anion exchange capacity. Kaolinite clay have higher CEC than montmorillonite or illite. The relative order of anion exchange is hydroxide, dihydrogen phosphate, sulfate, nitrate and chloride. Let us now see the importance of anion exchange in soil. It is important for release of fixed phosphate in soil. Generally, in acid soil, phosphate is fixed as insoluble aluminum phosphate. So, liming the acid soil release fixed phosphate. Significance of ion exchange in plant growth. Ion exchange is the second most important reaction in the world and first one being the photosynthesis. Usually plants take up their food material from soil through ion exchange. Each percent of humus contribute about 2 C mole per kg of CEC. That means 2 units of charge per cation. Soils with high CEC like clay soils can absorb higher amount of nutrients while sandy soils will have very low calcium exchange capacity. So in sandy soils, fertilizers are applied in split since it can absorb lesser amount of nutrients. Soil exchange complex with calcium will have desirable physical properties. When the exchange complex has cadmium, nickel and lead, they are toxic to plants. Clays with hydrogen ions are acidic while with sodium ions are alkaline in nature. Good friends, let us now see the milli-equivalent concept of cation exchange capacity. It refers to 1 milligram of hydrogen or the amount of any other ion that will combine with or displace it. 1 milli-equivalent is 1,000th of its atomic weight. The next important concept in examination point of view is buffering of soil, which means that the power to resist a change in soil pH. It helps in stabilization of soil pH. It also helps to determine the amount of amendment necessary to affect change in soil pH. What is base saturation? It is expressed in percentage, which means that percentage of cation exchange capacity that is satisfied by base forming cations. The formula is given here. Base saturation is calculated by dividing the exchangeable base forming cation in C mole per kg by cation exchange capacity in C mole per kg multiplied by 100. Example of acid forming ions are acidoids, which are aluminum and hydrogen, while base forming ions are basoids, and they are calcium, magnesium, potassium and sodium. What is exchangeable sodium percentage? It is defined as percentage of sodium in the total CEC, and it is calculated by using the formula, that is divide sodium by cation exchange capacity, and that is multiplied by 100. The usefulness of base saturation in soil, it helps in determining the quantity of lime that is required to raise pH of acid soils. It also helps in proportion of plant nutrients in cation exchange capacity. Fertile soil has base saturation percentage of more than 80. Well friends, so far we have seen cation exchange capacity in detail. The next one is the chemical property is soil pH. It is a measure of acidity or alkalinity or a soil by calculating the concentration of hydrogen ions in soil. pH scale has 14 and the pH less than 7 are called acidic, pH above 7 are called as alkaline, and pH 7 is called as neutral. Let us now discuss the measures that are to be taken place to overcome acidification, and they are liming to raise pH of acid soil, apply nitrate and sulfur according to the requirement and in a timely manner, use of good irrigation to minimize nutrient leaching, diversified crop rotation, apply calcium and magnesium bicarbonates containing irrigation water or manures or other organic materials, use of continuous no tillage, cover crops, application of manures and increase in organic matter and improve buffering capacity of soil. The one-liner is most important for the examination point of view. I will discuss one by one. Monomarlinate and vermiculite have higher cation exchange capacity than kyolinite, chlorite or illite. Percentage of sodium in the total cation exchange capacity is called as exchangeable sodium percentage, in short ESP. Kyolinate dominant clay have higher anion exchange capacity than monomarlinite or illite. Sandy soils have very low CEC. Power to resist a change in pH is called as buffering of soils. I will continue the explaining of one-liner. Negative charges attract positively charged ions and the positive charge attract negatively charged ions. Exchange of cation is called as cation exchange. Exchange of anion is called as anion exchange. Cation exchange phenomenon was first discovered by Thomsway in 1850. Ion exchange is the second most important reaction in nature. The first one is photosynthesis by green plants. Capacity of the soil to hold cation exchange capacity, the unit is C mole per kg. Capacity to hold anion exchange capacity, the unit is C mole per kg.
On behalf of Dr. K. Vanangamudi sir, I am presenting the question and answers. A soil is considered to be fertile when the base saturation percentage is, the correct answer is option D, more than 80%. The CEC of humus is about, the correct answer is option A, 200 to 400 centimole protons per kg. Third question is, the power to resist a change in pH is called as, the correct answer is option C, buffering action. The last question, acid soils are characterized by a pH of, the correct answer is option B, less than 6.
My dear friends, it is my personal request to all of you to improve your capacity to win your competitive examination successfully. Please kindly read my reading materials which are available with me. Also write weekly tests and mock tests which are being conducted by me. For getting these informations and details, text me at 9894904745 or mail me at vanangamudi.tnau@gmail.com. Thank you very much.